In the previous tutorial, we ended up with obvious gaps between the freeform blends, as they only align to the two edges that you pick. So for example, that wouldn't stitch together for a prototype model. But those ones were obvious to see. Up here, where I've taken off the fillet, we needed to use the continuity check to show that the long sections are positionally continuous, but the blends failed. But how is it judging the failure? Well, all the tools that work with continuity refer to a setting in our construction options, here in the tolerances section. And in continuity, there's a setting for G0 position, G1 tangent, and G2 curvature. So for example, the position tolerance is 0.01 millimeters, which is reasonable for a car. Now these are set by our construction presets, and we've been using the general CAD settings. But if we were doing product design on smaller objects, then we might use a different preset with a much tighter tolerance. So here 0.001 for example. So I'll go back to the general CAD settings and just take a look at the tangent setting. And so 0 degrees would be perfect tangency, so we're allowing for a 0.1 degree deviation. And for curvature, we've got this value of 0.1, which is actually much harder to interpret. So I'll show you an example later. Now, when you have a continuity locator, you can use the middle mouse button to get more information, and then the right mouse button to read a value at a specific point. So the gap here is 0.05, which is outside our tolerance of 0.01, which is why it's failed. Now, down here on the wheel arch, if you remember, we had a curvature failure. So I can do a continuity check again and pick these two edges. And if I now apply the middle mouse button to that, and then the right mouse button, it tells us we've got a curvature deviation of 0.12, which isn't really meaningful. So we tend to use a curvature failure as just a warning, and then we make our decisions based on the zebra stripes, which actually give us much more meaningful information. And you can see here that they look fine. So I could just leave it at that if I was concept modelling. But I'll have a go at fixing it, and because this small surface has lost its construction history, I'll need to use the Align tool. And it's already set up to G2 curvature, so I can modify this small surface and match it to the top one. But now I don't have enough CVs because I need one row for position, one for tangent, and one for curvature. So I've lost the shape at the bottom. So I can give it an extra row within the Align tool. And that's now kept its position. But I've also got these edge options here, and at the moment it's trying to align to this top curve. But if I switch these to skew, it stops doing that, and my CVs go back to their original position in this view. But the curvature is still being corrected in this view. And it's fixed here too because of the construction history. So I've finished with the Align tool, and I'll just delete all the locators. And then finally I'll go back to our corner blend. And the gap is too big to fix here, so I'll just need to rebuild it more accurately. And the only tools that give me continuity on four sides are the square and the bi-rail. So I'll just use square as an example, and I'll try to select the four boundaries. But this side here is split into two surfaces, and it won't let me pick it, as each edge needs to be a single curve or surface. So I'll need to do a bit more work and create a curve that I'll curve snap accurately to this end. And then up here it's really a matter of judgment to find the most relaxed position, and I might change that later. And at this stage I don't know what shape I'll need for this curve, so again I'll sort that out later. So I'll choose the square surface because it blends equally between each of the four boundaries, which I think will work best here. But on boundary number 1 I'll want curvature, and on 4 and 2 I'll need position to be accurate. So if I put the continuity check on, they're all fine. And I'll leave this one as free so that it can deviate if necessary. So if we take a look at the result, that's looking okay. So for the next one, I need to choose the surface and not the curve, so that the curvature continuity can be created between the two surfaces. And then I'll take position, and then this one now needs to be curvature, and then the last edge is position as well. So again, that's looking good. There's an extra isopalm, but that's okay. So how can I tell if that's a good result or not? Well, that's what the zebra stripes are good for. And you can see that I haven't got a particularly nice shape up here. And so this is where I can use the curve to reshape the surfaces. So I can pick those center CVs and move them and modify the surfaces. And I can improve that to give me a much better flow of highlights. And the second square has gone back to a single span as the shape is now much more relaxed. So with successful continuity, all the surfaces will now stitch together, so I could create a prototype or export it out to another CAD system. So we've covered quite a lot here. So if you want to go over it again, there's a golden rule and a theory builder that give much more information on the construction tolerances. And I go through them again in more detail in the second workflow section.